Hello.
Hello.
All right, so yes. Good morning, all you people in YouTube land. Okay, that one person that watches my views. Okay, good job, thank you. Okay, if I figure out who you are, you get a high five. So make sure you leave a comment and say, hey, it's me, and I will come around, give you a high five, maybe even a special sticker. I got a new pack of stickers today, so you could actually get like the Pacho YouTube sticker. All right, so other than that. Find the rate of change of the function. So, average rate of change, where x cannot equal c. Definition, instantaneous rate of change. So, instantaneous rate of change of f at c is the limit as x approaches c of the average rate of change, symbolically, looks like this. Provided the limit exists. Okay, good. We're going to get into other things in which the limit's not going to exist. I'm going to call them pointy points, but they're only pointy points on a graph. So if you're looking at a graph, it's going to be a pointy point. That means that it's not going to be a smooth. It's all of a sudden changing the direction of your slope from a positive to a negative without actually going to zero first. So a gradual change of a slope would go positive, 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 down to zero, and then it goes negative, 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 okay? So that's a gradual change, but a pointy point would be it's a positive, positive, then all of a sudden, negative, negative, okay? So there is no gradual, so it doesn't go to zero. So pointy point is going to be a sharp edge. We'll talk about that once we get, dang it, there we go. All right, so, next one, that's what I wanted. All right, find the rate of change of this function right here at c, any real number of c. So it's basically taking the limit, right? What does it say? Let's see, pause it. Okay, sorry, YouTube land. Had to line up my board, it wasn't working. All right, so we're taking the limit as x approaches c, and what is my c value here?
2.
So plug it at 2, and the function's going to be f of x, right? I keep saying f of x, but I'm like halfway there. So it's going to be x squared minus 5x. That's my f of x, right? Minus f of c, right? F of c. What is f of c? Negative 6. So it is 2 squared, which is going to give me 4 minus 10, which is negative 6. Okay. And on the bottom should be what? Now, I did this on purpose. I always put the minus first because that's probably going to be the biggest symbol mistake you guys are going to make. Is I put a minus because it's always minus f of c. So I put a minus there knowing it's going to be something, but then I put in my number. Then I put in whatever number I have there. So it's eventually going to be positive, isn't it? Yeah, good. So I'm going to end up with x squared minus 5x plus 6 over x minus 2. And you guys look at that, and everyone should say f that, right? So we're going to f that. Okay, so if we f that, what do we get? There we go. So it's going to be x minus 2 and x minus 3 over x minus 2, and we're still taking the limit as, x approaches 2, and then that's going to go away, so we get x minus 3, which is the limit as x approaches 2 of that, which is -1. So, -1. Okay, so what does that actually say?
It's the rate of change.
The rate of change, or also referred to as
Slope.
the slope, is going to be
-1.
when?
At
When x is 2, right?
x is 2.
Okay, that's what I'm looking for. So you have to be able to verbalize it and understand what it is we're talking about. So a lot of times you might understand like how to do the math, but you're not understanding why the math or what the math is. So if you keep understanding, it's just going to be the slope of the tangent line at when x is 2. Now, if I was to do this again for any real number c, I could actually try and, let's try it again. So let's try it again for any real number c. Tools, I know there's an insert. Did they change it here? Oh, no, it's insert. That's what I want. Insert, page, blank after current. So it's going to be limit as x approaches c of f of x, which is 5x squared. No,
X squared minus 5.
there you go. X squared minus 5x minus f of c, right? Which is going to be
C squared minus
c squared minus 5c, right? All over
x minus c.
x minus c. Okay, so a little bit of algebra. Let's do some algebra here. So I'm going to come up with x squared minus 5x minus c squared plus 5c over x minus c. Okay. All right, so now for this one right here,
Factor by grouping.
kind of can. You can take out our x, right? And I'm left with,
X minus 5.
take out a,
C.
and I'm left with positive c, right?
Yeah.
And I'm left with,
C plus 5. If you took out negative, it would look closer.
no. What was the problem on this one though?
Any rule.
What was the big rule?
X cannot equal C.
X cannot equal c. So x cannot equal c on that one. Flores, Drama, and Dulce. You guys are going somewhere to talk to someone. I don't know when. Okay, so pass, get those in a minute. All right, so why does this one not work out very well? We should actually look directly at the first part. Go back to it. X cannot equal c here, can it? I can't plug it in for c because c is the same thing. For any real number c, I can't plug in c. I would actually have to plug in any other value. So for any number, I would actually do the same steps all the way through, just to find my slope at that point. That's all I'm trying to get to, is getting to the slope at that point. Eventually, you guys are all going to end up at this one location where you're not going to have to do the algebra anymore. You're just going to say f prime of x is going to be 2x minus 5. And that's for any location. So right now we can't actually do that because we're not at that point yet. But because we have to be careful of what our C is. We can't actually do that. So we're going to get into this later this chapter. Not today. Finding the rate of change in a biological experiment. In metabolic experiment, the mass M of glucose decreases according to the function. Okay. Yes? Okay, so we know that the rate of this is doing what? Decreasing, right? It is changing, it's decreasing, isn't it? Yeah, because it's decreasing and it's also a negative, right? M is measured in grams, G is time. In hours, find the reaction at when T is equal to 1 hour. Okay, so we're doing the same thing. So limit, as for this case, is going to be T goes to 1, right? So it's 4.5 minus 0.03 T squared minus, because I'm minusing that, and then plug in 1, which is going to be, what's that? 4.47. Yes. Okay. All over x minus 1. Okay, so from there, go ahead, combine like terms. So as I distribute, I'm going to get what? 0.03 minus 0.03 T squared over x minus 1.
Where'd you get the 4.47?
Plug in 1 here. So it's 4.50 minus 0.03.
Plug in 1 for T?
Huh?
Plug in 1 for T?
Yeah, that's 1 for T.
Oh, because of T.
Yeah. So it's 1 squared, so that's what I'm doing. So I'm just subtracting that. Okay, sorry guys, kind of off my game today. I don't know. It's hard to keep too much NyQuil or DayQuil, whichever I took. Did I lose anyone? Yes.
Why do you have X at the bottom, not T?
Oh, you're right. You're right. It should be T. Thank you. Thank you. Thank you. T. Okay, can I factor anything out? Say yes.
Yes.
Okay, what can I factor out? 0.03, and I highly recommend also factor out a negative. It's going to change my problem. So if I factor out that negative 0.03, okay, so it's going to change the sign, so it's going to make this t squared positive, isn't it? So it's a positive t squared, and minus, because this is a positive, it's going to change to a minus 1, isn't it? Because I'm dividing out 0.03. So 0.03 divided by 0.03 is going to give me 1. And that lovely little thing, since the reason why I set it up like that is so now, can we see something special there?
Yes.
Yeah, the t squared minus 1 is difference of squares, so I could factor that further. So let me insert another page again. So I have negative 0.03 quantity t squared minus 1 over t minus 1. As I factor that, that's going to be negative 0.03 quantity t plus 1 and t minus 1 over t minus 1. Those lovely things right there go away. Now I'm doing the limit as t goes to 1 of negative 0.03 quantity t plus 1. Now can I take the limit as this and plug this 1 in? Okay, so 1 plus 1 is going to give me 2, right? So if I plug in the 1 plus 1 is 2. And then 2 times this is going to give me negative 0.06. Now, in this microbiological experiment, what does that actually mean now? Go back. We have to talk about it in words.
Doesn't mean it's decreasing at that rate.
It is decreasing. So, yes, it's decreasing at a rate of 0.06. But now go back to the word problem. Think about it. What is that? What is it saying?
That's the max at 1 hour is.
Yeah, remember, we got to go back to the word problem and actually insert whatever it is they're talking about. So, we're talking about the M, mass of glucose, right? So, as I plug it in for time, I get the mass of glucose from here, right? So, it is going down 0.06 every hour. But at that point, the rate is 0.06. But since this is t squared, as time goes on, does it goes down faster?
Yeah.
Yes, because it is t squared, it's going down faster as I go. So you guys have to use your words and explanation and talk about and use the information that is actually given to you. So if they're talking about mass, they're talking about glucose, and the word problem, you have to use those things. You can't just say, hey, the slope is this. Okay, now apply it to the problem. Okay, like I said, the word problems for AP testing is very precise because a lot of people are going to end up in biological sciences here. Okay, not everyone's going to be an engineer. Okay, different things actually go along with different stuff, and you're going to have a bunch of math problems that actually explain that. So when you're doing these things, you need to state clearly what it is in the problem that we're talking about. Does that make sense? Yeah, so not just yes, it's this, or no, it's that, or this number. So label what it is we're talking about. Did I answer everything? Yeah. All right, so Mike O'Callaghan, Pat Tillman Memorial Bridge spanning the Colorado River, opened in October 16, 2010. Having a span of 1,900 feet, is the longest arch bridge in the Western Hemisphere, and its roadway is 890 feet above the Colorado River. If a rock falls to the roadway at a function S, which normally applies to distance, in all my functions, S is referring to distance right there, is equal to F of t, where it's going to be 16t squared, gives the distance in feet. Okay, distance in feet. And the rock falls after t seconds between 0 and 7.458. Here, it takes this long, approximately, to fall the 890 feet into the river. Average velocity fall, the average velocity of the rock during its fall is, am I missing it? Is this not, am I missing part of this? You guys actually have it?
No.
No?
Is
Anyway, it's in the next part.
no.
Oh, it's right here. Anyway, all right, so,
This is really odd.
okay, I wasn't supposed to show that part, that's why. Dang it. Okay. Page. Okay, so, average velocity. So over the whole thing. So average velocity is asking for the whole thing, the whole time. Say yes. Okay, so whenever we're getting average velocity and we're not really given too much else, you have to go start to finish. So that's average. Instantaneous is actually at a specific point. Instantaneous is at a specific point. So average velocity would be find the slope basically in between. So it's the change in, so delta, okay, so delta, distance over time, S over delta T. So you will see this written out a lot like this. The little triangle means delta, and delta means the change. So if I start off with my height, what is my height going to be? 890, right? So it's 890 minus, okay, what is my end height? 0 over, starting time is over 7 point what? 458. Okay, if I do the math, it's going to come out to be 890 over negative 7.458.
Wait, how did you do that in your head?
How did I do what in my head?
The math. It's really
890 minus 0? Or the 0
Yeah.
minus 7.458?
all of it. That was really impressive.
I'm not getting a sarcasm vibe here. Are you really serious? Okay. All right, anyway. What I know about this rate, now just seeing it like this. What? Yeah, but what can I say about this rate? It's what? It's negative. So what does that mean? It's going down, right? So the velocity, it is going down. So the average, okay, it is going to be boop, going down to something. So I do the math, and it's going to be about, what is it about?
Oh man.
Y'all have calculators. Come on now. All right, and give me 3 decimal points because 3 decimal points are important for the AP. Is it like
Oh, that's a U. How did I find a U?
negative what?
Negative
119.
119.335.
Okay. And what is it changing? What is it changing? If it's a rate, it's changing something. A rate is miles per hour, liters per flush, miles per gallon. It's what? Distance over time. So what's my distance in?
Feet.
And my time is?
That doesn't seem right.
Why?
But no, I'm talking.
What part don't you like?
It's not negative. I know, but I could have the negative, but it's exact.
Okay. I'll check the settings on the calculator later because there might be a setting to automatically round it to 3. Okay, what does that mean though?
It is falling. That's
Okay.
feet per second, right? Yeah. So you drop
The
it.
distance of how fast it's falling.
Okay, watch this, watch.
It's like this.
You ready? You ready? You ready? Watch.
Whoa.
Wow.
So, when I was falling right there, was I falling at 119 feet per second? No. I wasn't. If I was for that, hold on, let me see if I can get a whole second up. Okay, probably a whole second there. All right. Anyway, if I was falling for that long, a whole second, at that speed, I'd be, right here, it would look like someone just dropped a tray of Jell-O. That's all that would be left. Okay? So, what does that mean?
That's how fast it
Think-
falls fast.
No?
That throughout all the time intervals, that's the average.
That's the average in between all of it, right? So at the beginning, are we actually falling that fast at the beginning?
No,
No. At the end, we're speeding up, right?
but we're not. We're falling faster at the end.
Yeah, at the end, we're falling faster. But that's the average speed over that time. Now does that make a little bit more sense? So that's the average. So at the beginning, I'm not going so fast, but at the end, I'm going super fast. Okay. All right. Okay, there. Bam. All right. Definition of instantaneous velocity. The velocity v of an object t sub naught is defined as the limit, the average velocity delta s over delta t as delta t approaches 0. Okay, so now we're trying to find it as, this is going to be instantaneous. I'm going to find it at a single point. Okay, so all this right here comes out to be my velocity. So isn't it the same thing I've been doing? So yes. Yeah, now it's just an application, a physics application of what we were doing. Okay, so now let's do the same thing after 1 second. So now I'm doing the limit, right? As t goes to 1, right? F of t, what was f of t?
For this one,
16t squared, right? Okay. All right, 16t squared minus. So,
Nope.
16, isn't it? Because it's f of t sub naught, and in this case, my t sub naught is, say, 1. Okay, because this is going to be t sub naught is 1. I don't know why I keep using black. I like red. I don't know why. All right, so it's going to be 16, right? Because t squared, so 1 squared is 1 times 16 over t minus 1. And I'm going to say we're going to do what? F that, right? 16 quantity t squared minus 1 over t minus 1, which is going to give me 16 quantity t plus 1, t minus 1 over t minus 1. My t minus 1's go away. And now I'm going to take the limit as t goes to 1 from 16 t plus 1. Plug in that limit. And what do we get?
Plug in.
It's going to be 32, right? So, what is that actually saying again?
At 1 second, it's at 1 second it's falling. At rate of 32.
Yes, it is falling, right? So it's falling. I could say it's going down, but if you notice, I don't have a negative on this one, do I? Because I'm talking about a different way of doing this. So if I'm doing it using the limit process like this, I have to talk about it. So it is falling. It's falling at 32 feet per second. Dang it. We're running out of time on this one. All right, so I will finish. I think this is actually my last part of the problem. Nope, I've got a couple more. I'll finish it up tomorrow. Okay, so, and tomorrow's going to be a homework day for you guys, so we'll finish this one up. And then don't forget, like, share, subscribe for that one person. High five.